Dear children, you are welcome to this channel. In the previous video, I have explained only three set of properties of inverse trigonometric functions. So in this video, let us continue the properties again. Okay. See, this is property, the set property 4, okay, which is called a reflection identities. Reflection identities. So what are they? Sine inverse of minus x is equal to minus sine inverse of x if x belongs to the closed interval minus 1 comma 1. Okay. Here sine inverse is a function, so the x should belongs to its domain, which is minus 1 comma 1. So likewise, next one is cos inverse of minus x is equal to pi minus cos inverse of x if x belongs to its domain minus 1 comma 1. See, you have to remember this identity like this. As a sine of minus theta is equal to minus sine theta. In this way, sine inverse of minus x is equal to minus sine inverse of x. But cos of minus theta will be equal to cos theta. So, here it is somewhat different. Cos inverse of minus x is equal to pi minus cos inverse of x. Okay. So, I think in exercise 4.1, this second identity has been given as a sum, third sum. Cos inverse of minus x is equal to pi minus cos inverse of x. You have to prove it. Okay. So the condition is not given, just simply we have given and we proved as a third sum there. Here it is given as that is an identity, and here the condition is given as x belongs to minus 1 comma 1. So while proving this, you have to use this condition where x belongs to minus 1 comma 1. Okay. Likewise, what is the third identity? Tan inverse of minus x is equal to minus tan inverse of x if x belongs to its domain R. And cot inverse of minus x is equal to pi minus cot inverse of x where x belongs to its domain R. And similarly, cosecant inverse of minus x is equal to minus cosecant inverse of x where x belongs to the domain R minus open interval minus 1 comma 1, and secant inverse of minus x is equal to pi minus secant inverse of x where x belongs to R minus 1 comma 1. As a secant is the reciprocal of cos, it has the same way, and then cosecant is the reciprocal of sine, it has like that. That one, cosecant of minus x, is similar to sine inverse of minus x. Okay. So let us prove the first one and the second one, so that the other four identities have a proof similar to these two. Okay. So let us prove the first one. So given that sine inverse of minus x. So first of all, you have to check whether sine inverse of minus x is well defined. Okay. You know that sine inverse is a function from minus 1 comma 1, that is whose domain is minus 1 comma 1 and whose range is minus pi by 2 to pi by 2. Okay. So given that x belongs to the closed interval minus 1 comma 1. This implies that as x belongs to minus 1 comma 1, clearly minus x also belongs to that interval, right? 1 comma 1. If x takes again 0.5 means minus x will be minus 0.5, again that belongs to this minus 1 comma 1. So whatever the value belongs to this interval, its negative also belongs to this same interval. It is clear. And therefore, we can say that sine inverse of minus x is well defined, right? That is well defined. Okay. Because this minus x belongs to this domain, so sine inverse of minus x is well defined. Therefore, let us take this sine inverse of minus x to be some theta. So where does theta belongs to? Theta belongs to the closed interval minus pi by 2 to pi by 2, that is range of sine inverse. That is from the definition it is clear. Okay. Now this implies that minus x is equal to sine theta. Okay. And then by definition, now interchanging this minus, we have x is equal to minus sine theta. Then absorbing this minus inside, you have minus sine theta is nothing but sine of minus theta. Okay. Moreover, for sine inverse, the angle should belongs to the fourth quadrant and the first quadrant. So minus sine theta will be equal to sine of minus theta, and minus theta lies in fourth quadrant. Therefore, we can rewrite this as sine of minus theta, where minus theta belongs to the fourth quadrant, that is in our required range. Okay. So that way you can interchange. We have to rewrite this as sine of minus theta. Again, by definition, moving the sign to opposite side, what we have? Sine inverse of x is equal to minus theta. Okay. Again, sine inverse of x is equal to minus theta. Now clearly theta belongs to this range, and therefore we can replace theta as the sine inverse of minus x. So that is equal to minus of sine inverse of minus x. Okay. Now move this minus to opposite side, and this implies that sine inverse of minus x is equal to minus sine inverse of x. Hence the proof. Okay. Do you understand this? Hence the proof. Then let us prove the second one, somewhat different. This is not similar to this. So it has been given as pi minus cos inverse of x. So let us prove that. Okay. So again, you know that cos inverse is a function from minus 1 comma closed interval minus 1 comma 1 to the closed interval 0 to pi. Okay. So here the range is the angles in the first quadrant and the second quadrant. Okay. Now again you are going to use the same proof, that is x, as x belongs to the closed interval minus 1 comma 1, minus x belongs to closed interval minus 1 comma 1. This is true, and therefore cos inverse of minus x is well defined. So as it is well defined, we can proceed. Now let us take cos inverse of minus x is equal to theta. Now where does this theta belongs to? Theta belongs to the closed interval 0 to pi. Okay. Then this implies that by definition minus x is equal to cos theta. Then as like in the previous case, let us interchange this minus to opposite. So we have x is equal to minus cos theta. But in the previous proof, we absorb this minus inside so that we wrote that the minus sine theta as a sine of minus theta, and moreover minus theta belongs to the fourth quadrant. Okay. But here theta belongs to the first and the second quadrant. Therefore, how to rewrite this minus cos theta means we have to rewrite this cos theta minus cos theta as cos of pi minus theta. Cos of pi minus theta is equal to minus cos theta, and moreover pi minus theta belongs to the required range. Okay. So we have to rewrite this one, and moreover we should not absorb this cos theta minus inside, because cos of minus theta is not equal to minus cos theta, and hence you have to rewrite this as cos of pi minus theta so that the angle belongs to the second quadrant. Okay. That is in the required range. Now interchanging this cos, we have cos inverse of x is equal to pi minus theta. As theta satisfies the required condition, we can replace this theta as cos inverse of minus x. Okay. Therefore, pi minus cos inverse of minus x. Again interchanging cos inverse of minus x and cos inverse of x, we have cos inverse of minus x is equal to pi minus cos inverse of x. That is hence the proof. So this is the way to prove this. So if it is given without the condition means you can prove as you have proved in the exercise 4.1. Okay. But if the condition x belongs to minus 1 comma 1 is given, you have to prove in this way. That is, you have to utilize this condition. Right. Similarly, the other proof, that is the proof of the other identities 3, 4, 5 and 6 follows like the same steps. So it is the similar proof. The proof is similar to this. Next set of property 5 is called cofunction inverse identities. Okay. So here there are 3 identities. What is the first identity? Sine inverse of x plus cos inverse of x is equal to pi by 2, where x belongs to the closed interval minus 1 comma 1. See, this closed interval minus 1 comma 1 is the domain of both the sine inverse and cos inverse. So here x belongs to their domain, right? Similarly, what is the second identity? Tan inverse of x plus cot inverse of x is equal to pi by 2, where x belongs to R, where R is the domain of both the tan inverse of x and cot inverse of x. And the third identity is cosecant inverse of x plus secant inverse of x is equal to pi by 2, where x belongs to R minus open interval minus 1 comma 1. This is nothing but the domain of cosecant inverse as well as the secant inverse. So they have been paired, okay, as they have the same domain. Now to start with here let me prove the first one and the second one, and the proof of the third one is similar to the proof of the first. So let me prove the first and the second, right? Now to prove the first one, as x belongs to minus 1 comma 1, which is nothing but the domain of sine inverse and cos inverse of x and cos inverse of x are well defined. Okay, so they have well defined. So let us assume sine inverse of x. Let us assume sine inverse of x to be theta. So you know that theta belongs to theta belongs to which interval? Minus closed interval minus pi by 2 to pi by 2 according to the definition of sine inverse, right? And this implies that sine theta is equal to x, right? That is x is equal to sine theta. So that is x is equal to sine theta. Now we are going to represent this sine theta as cos of pi by 2 minus theta. Now that means a corresponding angle. For theta lies in this quadrant, pi by 2 minus theta lies in the closed interval 0 to pi, which is the range for cos inverse. Okay, so let me explain this also. So here minus pi by 2 less than theta less than pi by 2, sorry, less than or equal to, because it is closed interval, so you have to put the equal to sign. If it is open interval, that is simply less than symbol should come here. Okay, now let us multiply throughout by 1 minus. So what happened? Pi by 2. When you multiply by minus, the inequality gets reversed. So it will be minus theta greater than or equal to minus pi by 2. Okay. Now add pi by 2 throughout. So pi by 2 plus pi by 2 greater than or equal to pi by 2 minus theta is greater than or equal to pi by 2 minus pi by 2. So this is nothing but pi greater than or equal to pi by 2 minus theta greater than or equal to 0. That is 0 less than or equal to pi by 2 minus theta less than or equal to pi. So for corresponding theta lies in this quadrant, that is fourth and the first, the corresponding value of pi by 2 minus theta lies in the first quadrant and the second quadrant. So this is for sine inverse, means the corresponding theta pi by 2 minus theta lies in the second and first quadrant for cos inverse. Therefore we have to replace sine theta by cos of pi by 2 minus theta. Okay. Now this is also true, cos of pi by 2 minus theta is equal to sine theta, and moreover pi by 2 minus theta lies in 0 to pi when theta belongs to minus pi by 2 to pi by 2. Okay, so this is cos of pi by 2 minus theta. Now again moving cos to opposite side, we have cos inverse of x is equal to pi by 2 minus theta, and then replacing theta you have pi by 2 minus sine inverse of x. Then moving the sine inverse to opposite side, we have sine inverse of x plus cos inverse of x is equal to pi by 2. Okay. So do you understand this? So while changing the sign to cos, there are so many relations are there, but you have to find out the corresponding angle in such a way that they belongs to the respective ranges. Okay. So where if we take theta belongs to this range, and we have to show that find out the corresponding angle which belongs to the range of the cos inverse. So that is pi by 2 minus theta. Okay. Now similarly for the second one, for tan inverse of x, as x belongs to real number, that is entire real number R, we can write that tan inverse of x and cot inverse of x are well defined, because the domain for tan inverse of x and the cot inverse of x is R, and here x belongs to R, therefore we can define tan inverse of x and cot inverse of x. Okay, so that is true. Now that is tan inverse of x and cot inverse of x exist. Okay, so let us take this as tan inverse of x to be some theta. Okay, now where this instead of tan inverse of x, let us take cot inverse of x to be theta here. Okay, so if we take a cot inverse of x theta, where should theta belongs to? Theta belongs to the open interval 0 comma pi. So 0 comma pi is the range for cot inverse, so it be theta belongs to the open interval 0 comma pi. Now by definition we have x is equal to, this implies x is equal to cot theta. Okay, now we can rewrite this cot theta as tan of pi by 2 minus theta. Okay, as in the previous case, but you have to check whether pi by 2 minus theta lies in the corresponding range of tan inverse, which is nothing but open interval minus pi by 2 to pi by 2. So you have to check. So let us check whether it lies, okay, pi by 2 minus theta lies in the corresponding range of tan inverse, okay. So for that, here theta belongs to the open interval 0 to pi, that is 0 less than theta less than pi. Here as it is an open interval, you shouldn't write equal to sign, right? Now again let us throughout multiply by minus. So what happened? 0. The inequality will get reversed. Minus theta is greater than minus pi, right? Then adding pi by 2 as in the previous case, like that, pi by 2 plus 0 greater than pi by 2 minus theta is greater than pi by 2 minus pi. That is pi by 2 is greater than pi by 2 minus theta is greater than minus pi by 2. So that is minus pi by 2 is less than pi by 2 minus theta less than pi by 2. This implies that pi by 2 minus theta belongs to the open interval minus pi by 2 to pi by 2. Okay. So we have taken theta belongs to the closed open interval 0 to pi, and we have shown that corresponding angle pi by 2 minus theta belongs to the open interval minus pi by 2 to pi by 2. So for tan, you have to, that angle should belongs to this range, and for cot the angle should belongs to this range. So if we take theta, and here we have shown that pi by 2 minus theta belongs to the respective range of tan inverse, so that we can write cot theta is equal to tan of pi by 2 minus theta, okay. Then taking inverse, we have tan inverse of x is equal to pi by 2 minus theta, and clearly for tan inverse this pi by 2 minus theta should belongs to this, and we have proved that pi by 2 minus theta belongs to the open interval minus pi by 2 to pi by 2. So we have shown that. So the output x is belongs to the respective range of tan inverse, okay. We have proved this. So tan inverse of x is equal to pi by 2 minus theta holds good. Now replacing this theta by cot theta, replacing this theta by cot inverse of x, we have tan inverse of x is equal to pi by 2 minus cot inverse of x, and then rearranging we have tan inverse of x plus cot inverse of x is equal to pi by 2, okay. So do you understand this? Here even you can write that this implies pi by 2 minus theta belongs to the closed interval 0 to pi, okay. See, in exercise 4.2, as in eighth sum, we have eighth sum, we have one subdivision as find the value of cos inverse of 4 by 5 plus sin inverse of 4 by 5, okay. So there, you find out, we took a right triangle and we found out cos theta sin theta, and we used this. We found the value of this one. But here, after reading the property, that is cofunction inverse identity, now we can utilize the identity here. Look at this. This is called, look at it is in the form cos inverse of x plus sin inverse of x, where this x 4 by 5 belongs to the closed interval minus 1 comma 1. So we can apply the identity here, okay. Now 4 by 5 belongs to the closed interval minus 1 comma 1, and therefore cos inverse of 4 by 5 plus sin inverse of 4 by 5 is equal to pi by 2, because cos inverse of x plus sin inverse of x is equal to pi by 2 if x belongs to the closed interval minus 1 comma 1. This is one of the cofunction inverse identity, okay. So therefore the given problem, that is cos inverse of 4 by 5 plus sin inverse of 4 by 5 is equal to cos of pi by 2. Then what is cos 90? Cos 90 is equal to 0. So after reading the property, the problem is we can reach the answer of the problem in a very few steps, okay, in few steps. So the property helps you to find out the answer. Then sixth set of property, okay. It has 6 identities, and what are they? The first one is sin inverse of x plus sin inverse of y is equal to sin inverse of x into root of 1 minus y squared plus y into root of 1 minus x squared, and this holds good either x squared plus y squared is less than or equal to 1 or xy is less than 0, okay. Then the second one is sine inverse of x minus sine inverse of y is equal to sine inverse of x into root of 1 minus y squared minus y into root of 1 minus x squared, where x squared plus y squared is less than or equal to 1 or xy is greater than 0. Okay. And then third one is cos inverse of x plus cos inverse of y is equal to cos inverse of xy minus root of 1 minus x squared into 1 minus y squared, where x plus y is greater than or equal to 0. And fourth identity is cos inverse of x minus cos inverse of y is equal to cos inverse of xy plus root of 1 minus x squared into root of 1 minus y squared if x is less than or equal to y. Then tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus xy if xy is less than 1. And the tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy if xy is greater than minus 1. Okay. So while doing problems, don't bother about the conditions. They will give this x and y which satisfies the conditions. Okay. So no need to check the condition. Directly you can apply the formula while doing problems. Now let us prove the first one. So the proof of the first one. So sine inverse of x and sine inverse of y are given, okay, in the left hand side. So let us take sine inverse of x to be some theta and sine inverse of y to be some pi, angle pi, okay, angle phi. Now, and clearly theta comma pi belongs to, okay, minus pi by 2 to pi by 2, the closed interval minus pi by 2 to pi by 2, because for sine inverse the output should belongs to this interval, okay, that is the range. So theta and pi belongs to this interval. And then and what would be x and y? Where should x, y and y belongs to? X and y belongs to its range, that is closed interval minus 1 comma 1. Also we can rewrite this as x belongs to the closed interval, we can also rewrite this as modulus of x is less than or equal to 1 or modulus of y is less than or equal to 1. Okay. So this one can also be written in this way. Now sine inverse of x is equal to theta and sine inverse of y is equal to pi implies x is equal to sine theta and y is equal to sine pi. Okay. Now as theta and pi belongs to the closed interval minus pi by 2 to pi by 2, that is in first quadrant and the fourth quadrant, cos is also positive because in first and fourth cos theta, cos value will be positive. Therefore cos theta comma cos pi is positive as theta comma pi belongs to the closed interval minus pi by 2 to pi by 2. Okay. So clear, make it clear that cos theta and cos pi will be positive for these angles theta and pi, right? And therefore after getting sin theta and as x as sin theta and y as sin pi, let us find out cos theta. So cos theta will be root of 1 minus sin squared theta, that is equal to root of 1 minus x squared. So as cos theta is positive, we have taken the positive value. Okay. And similarly cos pi is equal to root of 1 minus sin squared pi, that is equal to root of 1 minus y squared. As cos pi is positive, we have taken the positive value. Now let us find out what is the sine of theta plus pi. Sine of theta plus pi is equal to sin theta into cos pi according to the compound angle formula, then plus cos theta into sin pi. Okay. Now replace the corresponding values in x and y. So what is sin theta? Sin theta is x and cos pi is root of 1 minus y squared plus cos theta is root of 1 minus x squared and sin pi is y. So y into root of 1 minus x squared. Okay. Then interchanging the sign to opposite side, we have theta plus pi is equal to sine inverse of x into root of 1 minus y squared plus y into root of 1 minus x squared. Okay. Now replacing theta and pi, we have sine inverse of x plus sine inverse of y is equal to sine inverse of x into root of 1 minus y squared plus y into root of 1 minus x squared. Okay. So this is the proof. but there we have not used the condition that x squared plus y squared is less than or equal to 1. Okay, so let us see that, because they have given either this condition holds good or this condition holds good to do the identity property. Okay, so let us explain this again here. So this is the way of proving the property, but you have to check whether for at this step sine inverse of this expression is equal to, this value is equal to theta plus pi, means you have to check whether theta plus pi belongs to this interval minus pi by 2 to plus pi by 2. Okay, this is the output. So you have to check whether this output belongs to this range. So for that you have to use the condition x squared plus y squared is less than or equal to 1. Okay, so as modulus of x and modulus of y is less than 1, that means x squared is less than or equal to 1 and y squared is less than or equal to 1. So this implies x squared plus y squared is less than or equal to 1. Okay, x squared plus y squared is less than or equal to 1. That means that x squared is less than or equal to 1 minus y squared, or taking square root we have modulus of x is less than or equal to root of 1 minus y squared. Similarly, modulus of y is also less than or equal to root of 1 minus x squared. Therefore, if you multiply we have, that is modulus of x into modulus of y is simply, we can write it as simply xy is less than or equal to root of 1 minus y squared into root of 1 minus x squared, or moving this to opposite side we have root of 1 minus x squared into root of 1 minus y squared minus xy is greater than or equal to 0. Okay, now if we take cos of theta plus pi, then according to the compound angle formula it will be cos theta into cos pi minus sin theta into sin pi. Okay, that is cos theta is root of 1 minus x squared and cos pi is root of 1 minus y squared minus sin theta is x and sin pi is y. Okay, so this is root of 1 minus x squared, therefore cos inverse. So if you move this, theta plus pi is equal to cos inverse of root of 1 minus x squared into root of 1 minus y squared minus xy. Okay, now as this is cos inverse, sorry, no need to move it to cos inverse, simply we can have this, at least we can stop up to this step, but this is greater than or equal to 0. So cos of theta plus pi is greater than or equal to 0, because root of 1 minus x squared into root of 1 minus x squared minus xy is greater than or equal to 0 by taking the condition that x squared plus y squared is less than or equal to 1. So we have achieved this result. So from this result we got cos of theta plus pi is greater than or equal to 0. So for what angle cos will be 0? For the angles in the first quadrant as well as in the angle in the fourth quadrant. This implies that theta plus pi belongs to the closed interval minus pi by 2 to pi by 2. Okay, so do you understand this? By taking the condition that x squared plus y squared is less than or equal to 1, we have proved the result that theta plus pi belongs to the interval, closed interval minus pi by 2 to pi by 2. That means that here sin inverse of this x into root of 1 minus y squared plus y into root of 1 minus x squared is equal to theta plus pi, and therefore this as theta plus pi belongs to this closed interval minus pi by 2 to pi by 2, this holds good, that is sin inverse of x into root of 1 minus y squared plus y into root of 1 minus x squared is equal to theta pi plus pi holds good. Therefore we can replace theta as sin inverse of x and sin inverse of y. Okay, similarly we can prove the other results. Okay, see, if in case if they are asked to prove the property, means it is enough if you give the proof, like if you give this proof, this is for your understanding, so no need to give this, no need to write this, this is for your understanding, this is for your understanding, so it is enough if you give this proof. Okay, if in case if it is asked, and then you can also, but one more condition is there, and if you want to take this condition, means you have to go into some depth, that depth is not necessary for you, so leave it. Okay.